Hello students, welcome to Abdemi. In today's session, we consider an interesting problem involving hyperbola and circle. Let us see what that problem is. See the problem. Tangents are drawn from any point of the hyperbola x square by 9 minus y square by 4 equal to 1 to the circle x square plus y square equal to 9. Find the locus of midpoint of the chord of contact. So just think of this hyperbola and this circle first. So there is a circle. This is x-axis, this is y-axis, this is center, which is nothing but 0, 0, and the equation of the circle is given as x square plus y square equal to 9. And there is a hyperbola whose equation is x square by 9 minus y square by 4 equal to 1. Okay, so for this hyperbola, so I can write from this x square by 3 square minus y square by 2 square is equal to 1. So for this circle, the vertices are minus 3, 0 and 3, 0. And this circle also cuts x-axis at minus 3, 0, 3, 0. So the hyperbola will look like this, something like that. So this is the hyperbola, two branches of the hyperbola, and this point's coordinate is minus 3, 0, and this point's coordinate is 3, 0. So the look of hyperbola is this one, and look of circle is this, and they have common points. Say I call it V1, V2, V1, V2. Okay, V1, V2's coordinates are, this is V2 minus 3, 0, and this is V1. Okay, so this is the look of the parabola, circle and hyperbola. Now, tangents are drawn from any point on the hyperbola. So, take any point on the hyperbola. From that point, you draw tangents to the circle. So this is the external point to the circle. So this is one tangent, this is another tangent. Find the locus of midpoint of the chord of contact. So these are the point of contacts of these tangents in the circle. So this is the chord of contact. Now what is the locus of the midpoint of chord of contact? Chord of contact, that is to be seen. So just let us see this thing diagram in a better way. See, this is the diagram. So this is the circle. This circle's equation is actually x square plus y square equal to 9. That means radius is 3. And this circle passes through 3, 0 and minus 3, 0. Because 3, 0 satisfies this equation, minus 3, 0 also satisfies this equation. And this is the hyperbola whose equation is x square by 3 square x square by 3 square minus y square by 2 square is equal to 1. So this is the hyperbola, and vertices of the hyperbola are 3, 0 and minus 3, 0, and these 2 points are 3, 0 minus 3, 0, and these 2 points are common to both parabola, both hyperbola and the circle. Okay, and this is a point on the hyperbola from which 2 tangents are drawn to the circle, and the point of contacts are this T1 and T2. So if I join T1 and T2, so T1, T2 becomes chord of contact. Chord of contact, COC, chord of contact. Okay, now for different points, if I take different points on the hyperbola, I can draw many different pair of tangents and I can get many different chord of contacts. So what is the locus of the midpoint of such chord of contacts? That is to be determined. Okay, now for that let us do some background work of coordinate geometry that is very useful. So let us talk about the chord. Let us try to find out the equation of chord of contact, how it can be done. I hope it will be very useful for you. So this is a circle. This is a general circle whose equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay, and there is a external point. So the center of the circle is minus g minus f, all you know, all those things. So this is the center of the circle. Now take an external point, a point outside the circle P whose coordinate is say x0, y0. Okay, now from P draw a tangent here and draw another tangent here. So from external point I can draw two tangents to the circle and call these points of contacts T1 and T2. Okay, now this T1 T2 line is called the chord of contact for this circle. Okay, now T1 T2's coordinate, let it be x1 y1 and x2 y2. All right. Now, what is the equation of the tangent at equation of tangent at T1? What is the equation of tangent of T1 when the equation of the circle is given? So we know how to do that. So I can readily write wherever x square is there, I replace x by x1, and wherever 2x is there, I replace it 2x by x plus x1. So this thing we know from our basic knowledge on coordinate geometry. So at the point x1, y1, the equation of tangent at T1, which is x1, y1, is x1 plus y1 plus g x plus x1 plus f y plus y1 plus c equal to 0. So this is the equation of tangent. So let me, T2's coordinate is actually x2 y2. So this is the equation of the tangent at T1. And similarly, equation of tangent to the circle at T2, which coordinate is x2, y2, is what? x2 plus y2 plus g x plus x2 plus f y plus y2 plus c equal to 0. This is equation number 2. Now see, this is one tangent equation, this is another tangent equation. Now both the tangents actually pass through point P, because from P I have drawn two tangents, PT1 and PT2. Since both the tangents pass through P, we can write from 1, I can write x0 x1 plus y0 y1 plus g x0 plus x1 plus f y0 plus y1 plus c equal to 0. So I call it 3, equation, relation 3. It is not equation, we had only, it is relation between x0, y0, x1, y1. And similarly, this equation must satisfy x0, y0, y0 must satisfy equation number 2 also. So I can write x0, x2 plus y0, y2 plus g x0 plus x2 plus f y0 plus y2 plus c equal to 0. So this is equation relation number 4. Okay. Now careful look into this 3 and 4 reveals a fact that if I write a equation like x naught, consider this particular equation. Consider the linear equation. Consider the following linear equation. What is that equation? I am writing x naught plus y naught. Carefully follow what I am doing. Plus g x naught plus x plus f y naught plus y plus c equal to 0. Call this equation, call this equation 5. Consider equation 5, which is x naught y naught plus g x naught plus x plus f y naught plus y plus c equal to 0. Call it 5. Now it is very clear, equation 5 is satisfied by the coordinates of points T1 and T2. Why? Because x1, y1 satisfies this equation, because we have already obtained this relation x0, x1 plus y0, y1 plus g x0, x1, x0 plus x1 plus f y0 plus y1 plus c equal to 0. That means this equation is satisfied by x1, y1 as well as x2, y2. But this equation is what? If I properly write this equation, it is actually x naught plus g. If I just take x out, x naught plus g x plus y naught plus f y plus gx naught plus fy naught plus c equal to 0. So this equation I can write like this. So I can write x naught plus gx plus y naught plus y naught plus f y, this is y naught plus fy plus gx naught, it comes from here, fy naught plus c. So this equation is of the form ax plus by plus some constant k equal to 0. So I can write equation 5 is of the form ax plus by plus k equal to 0, which is a linear equation in x and y. And any linear equation in x and y with respect to a coordinate system represents a straight line. So this equation is therefore equation 5 represents a straight line. Okay, I think there is no doubt in it. Represents a straight line, and not only that, and this straight line is satisfied by the points coordinates of T1 and T2. And T1, T2 lies on that straight line. Therefore, equation 5, this equation, is the equation of a straight line on which points T1 and T2 lie. So, you know, if two different points are given, then I can have only one straight line connecting these two points. So it is therefore equation 5 represents the equation of the line T1, T2. Therefore, equation 5 is the equation of COC, chord of contact T1, T2. So equation of T1, T2, which is nothing but the chord of contact, is represented by 5. Now what this 5 represent? So just let me, so if you have understood this, so equation of the chord of contact is this one. Now let us do little further analysis. So what I do, so I have already found the equation of the chord of contact. So what is that? Let me rewrite the equation once again. You try to follow the steps very carefully, because this is a very, very useful concept in coordinate geometry, and this concept is applicable for all the different types of conics like parabola, ellipse, hyperbola, etc., including circle. So we have already obtained the equation of COC, as x0 plus y0 plus g x0 plus x plus f y0 plus y plus c equal to 0. This is the equation of the chord of contact COC. COC, this is the equation of T1, T2, that is COC. Now, what this equation represent? From the look of the equation, we can think that it is the equation of the tangent. The equation is the same form as the equation of the tangent of the circle, as if x0 y0 is lying on the circle. So x0 y0, we know it is not lying on the circle, but had it lied on the circle itself, then the equation of the tangent at P for the circle would be written like Tp could be written like x0, because x0 plus y0 plus g x plus x0 plus f y plus y0 plus c equal to 0. So the equation of the COC looks like this, Tp equal to 0. So write the equation of the tangent to the circle, assuming that the external point x0, y0 is lying on the circle. Though x0, y0 is actually not lying on the circle, but assume as if x0, y0 is lying on the circle. Hypothetically assume that x0, y0 is lying on the circle. Had x0, y0 had it lied on the circle itself, the equation of the tangent at that point would look like this: x0 plus y0 plus gx plus x0 plus fy plus y0 plus c equal to 0. So this is a easy to remember type form, easy to remember. So without doing any analysis, you can readily write the equation of the COC, chord of contact, looks like Tp equal to 0. P is the external point. As if you write down the equation of the tangent at the point P, if P, assuming P is lying on the circle. So this is the form of the equation of the COC. x0 plus y0 plus gx plus x0 plus fy plus y0 plus c equal to 0. So tangent, if x0 y0 had lied on the circle, the tangent at that point would look like this. Actually, this is not the equation of the tangent, this is the equation of the COC. So this is the standard technique. Tp equal to compute the equation of tangent at the point P, assuming P is lying on this circle. Again, I am telling, point of caution, P is actually not lying on the circle. Assuming P is lying on the circle, if I could write the equation of the tangent at P, then the form would look like this. So Tp equal to 0 is the form of equation of the COC. Okay, so this is one important technique, and it will be useful in solving the given problem. Another aspect that I want to consider here is that if the midpoint of the chord of contact is given, then how to find the equation of the COC? Let us see that. That is also very useful. So for the circle, again I am considering this circle, and this equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. I can write this as S. So S equal to 0 is the equation of the circle. It will be handy afterwards. We'll see how it is. So consider then external point P, which is x naught, y naught, and from P you draw two tangents to the circle. So this point is T1, this point is T2. Assume as usual its coordinate is x1, y1 and T2's coordinate is x2, y2. Okay, now since I want to find out the equation of the chord of contact, and it is given that the midpoint of this chord of contact is HK. Say it is HK. This point is T1, T2. So HK is a point of midpoint of a chord of contact. Then how the equation will look like? So equation of the COC will look like. Now see this equation of circle, equation of chord of contact I can write is, since x1, y1 and x2, y2 are lying on the circle, so equation of T1, T2 I can write, since this chord of contact is passing through the point HK, so I can write y minus k is equal to m x minus h, where m is the gradient of this line, and which is nothing but y2 minus y1 by x2 minus x1 x minus h. Okay, now from this equation, since both x1 y1 and x2 y2 are lying on this circle, so both x1 y1 and x2 y2 must satisfy the equation of the circle. So this is COC T1 T2. So this is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. We can write like this, and x2 square, since x2 y2 is also satisfying the equation of the circle, so I can write 2gx2 plus 2fy2 plus c equal to 0. So if I take difference of these two, so I can write x2 square minus x1 square plus y2 square minus y1 square plus 2g x2 minus x1 plus 2f y2 minus y1 is equal to 0. I can write like this. So from this I can write, or I can write x2 minus x1 into x2 plus x1 plus y2 minus y1 into y2 plus y1 plus 2g x2 minus x1 plus 2f y2 minus y1 equal to 0. I can write that, but since HK is the midpoint of HK, M is midpoint of T1, T2. Okay, so H is nothing but x1 plus x2 by 2, and K is nothing but y1 plus y2 by 2. So what I do, I can write x2 minus x1 into 2h plus y2 minus y1 multiplied by 2k plus 2g x2 minus x1 plus 2f y2 minus y1 is equal to 0. I can write like this. So I can cancel all the 2's from there. So I can write, or if I take x2 minus x1, then h plus g plus y2 minus y1 k plus f equal to 0. Or I can write x2 minus, or I can write y2 minus y1 divided by x2 minus x1 is equal to minus g plus h by f plus k. I can write like that because y2 minus y1 into f plus k plus x2 minus x1 into g plus h is 0. Okay. So what I do, I substitute this value here. So equation of COP COC T1 T2 is actually y minus k is minus g plus h by f plus k. It is x minus h. All right. So this is the equation of T1 T2. This is the equation of COC. So if I just cross multiply, so it is y minus k into f plus k equal to minus g plus h into x minus h. So I can write, I can take all the things in the left and I can write this plus this equal to 0. No problem. So, or I can write yf minus kf minus k square, yf minus kf minus k square plus ky plus gx plus hx minus gh minus h square equal to 0. Try to follow the steps. So what is happening? So what I do, I write this term, I take hx plus ky. This term I am writing plus ky plus this term you write gx. Okay. Then I take this term gx and yf, this term. So I am left with whatever terms, I bring it in the other side of the equation. So I take k square plus h square, k square I am bringing that side, h square I am bringing that side, then gh and kf plus gh plus kf. Okay. Now what I do, I just take this thing gh, add gh and kf on both sides actually. So what I do, I write hx plus ky plus g x plus h. So I have added a term gh, and similarly I add kf on this side also. So it is f y plus k. So this side it becomes k square plus h square plus 2gh plus 2kf. Okay, now let us further simplify the things. So I just recast this equation in a different form. For that, what we do, let us follow. So whatever we have obtained so far, so I write hx plus ky plus g x plus h plus f y plus k, and I add a c here and here also in the right hand side also I add a c. So it is k square h square plus k square plus 2gh plus 2kf 2fk plus c, because I have added c here, c here. So now see what this LHS represent. LHS represent as if I am writing the equation of tangent to the circle at the point hk, assuming hk is lying on the circle. Though hk is not lying on the circle, it is interior to the circle, but if hk, assuming that hk is lying on the circle, the equation of the tangent to the circle at hk will look like this: hx plus ky plus g, 2x I am replacing by x plus h, 2y I am replacing by y plus k plus c, and here it is actually the equation of the circle, this equation at the point hk, the left hand side of the equation of circle at the point hk, it looks like this. So I write this as Tm, as if the form of the equation of the right hand side of the equation of the tangent, if it is computed at the point hk, then this will look like this: hx plus ky plus gx plus h plus f y plus k plus c is equal to, so equation of the circle is s equal to 0. So Sm is the left hand side of the equation of the circle at point M. So Tm is equal to Sm is the equation of the COC, which is T1, T2 or COC, code of contact. So this is the equation of the code of contact. So far we have learned that if this point is called P, then the code of contact T1, T2 can be expressed in two forms. One is actually Tp equal to 0. Another form is Tm is equal to Sm. Okay, so Tp equal to 0 means, assuming the point P is lying on the circle, at this point, what is the equation of the tangent to the circle? So this is, by this notation, I mean write down the equation of the tangent to the circle at the point P. P is x0, y0, assuming P is lying on the circle. Similarly, the same COC's equation, code of contact, I can write, provided the midpoint of the code of contact is given, then the code of contact's equation can be written like Tm equal to Sm. But Tm is equation of the tangent to the circle at the point M, assuming this point M is lying on the circle. The form will be like this: and SM, S is the equation of the circle, right hand side of the equation of the circle, and equation of the circle satisfied at the point M. So TM equal to SM. Okay. Now these two things will be very useful for our computation. Okay. Now let us go to the problem. So with this background, let us go to the problem. Now see what is the equation of the, so here the equation of the hyperbola is x square by 9 minus y square by 4 equal to 1. Okay, so equation of hyperbola is x square by 9 minus y square by 4 equal to 1. So in the parametric form, I can write any point on the hyperbola can be considered as three sec theta to cot theta, because sec square theta minus cot square theta, this is sec theta tan theta, sorry. Because this sec, if I substitute this point over there, sec square theta minus tan square theta, LHS of this equation, if I substitute sec square theta minus tan square theta, so it is 1 minus sin square theta by cos square theta, so it is 1. So sec square theta minus tan square theta equal to 1, that means this point automatically satisfies the equation of the hyperbola, and therefore 3 sec theta 2 tan theta is a point on the hyperbola. Now from this point, this is point P whose coordinate is 3 sec theta 2 tan theta. Okay, so from that I have drawn two tangents. So these are T1, T2. Okay, to the circle, and circle's equation, this circle's equation is x square plus y square equal to 9, or AC equal to, or I can write this thing x square plus y square minus 9 equal to 0, or I can write S equal to 0, where S is x square plus y square minus 9. Now this is the chord of contact. Okay, now equation of chord of contact I can write as T P 0. So as if 3 sec theta 2 tan theta point lies on this circle, what would be the equation of the tangent at that point? So readily I can write x into 3 sec theta plus y into 2 tan theta is equal to 9. Okay, so 3 sec theta, 3x sec theta plus 2y tan theta equal to 9. This is the, because if you take Tp equal to 0, so this minus 9 is equal to 0, so I can write like this, Tp equal to 0. So I just take this minus 9 here, so it is minus 9 equal to 0. So this is the equation of COC. COC can be given like this. This is 1. Okay. Now consider HK is the midpoint of this line T1, T2. Therefore, the equation of COC chord of contact can also be written as Tm equal to Sm. So Tm is as if Hk is lying on this circle. So how the equation looks like? So it is Hx plus Ky minus 9. I can readily write from this is equal to H square plus K square minus 9. I can write applying this technique just what we have learned now. So this is Hx plus Ky equal to H square plus K square. Assuming Hk is the midpoint of this COC T1, T2, I can write the equation of COC again as Hx plus Ky minus 9 is equal to H square plus K square minus 9, or Hx plus Ky equal to H square plus K square. Okay. Now both equation 1 and 2 represent the same line, same equation basically. So what I can do? So here actually I rewrite this as equal to 9. That will be convenient. Okay. So 3 sec theta plus y into 2 tan theta equal to 9. So these two equations are identical. So I can compare the coefficients of x, coefficients of y and the constant terms, and their ratios will be equal. So I can write 3 sec theta. So I can write 3 sec theta from 1 and 2. 1 and 2 both represent the same line, which is T1, T2, which is chord of contact. So 3 sec theta divided by h equal to 2 tan theta by k equal to 9 by h square plus k square. I am interested to find the locus of hk. So from this equation, if I can eliminate theta, then I can find the relation involving hk. From that I can find the equation of locus by replacing h by x and k by y. This is the standard technique, you know. So what is sec theta? Sec theta is how much? 3 sec theta is equal to 9h by h square plus k square. Okay, so h square plus k square divided by h is equal to 3 cos theta. I can write h square plus k square by h is equal to 3 cos theta. So cos square theta is actually h square plus k square whole square divided by 9h square. So I can write this as number 3. And I can also write that tan theta. So what I do, rather let me write like this. Instead of doing like this, let us keep it in the form of sec theta only. That will be convenient, I think. So I can write sec theta equal to 3h by h square plus k square. Therefore sec square theta is 9h square by a square plus k square whole square. And then tan theta is how much? Tan theta is 9 by 2 k by a square plus k square. Therefore, tan square theta is 81 by 4 k square a square plus k square whole square. So, sec square theta minus tan square theta is 1. Okay, so I can write from this expression what I can do. See, so from this calculation I can write what I can write, sec square theta minus tan square theta equal to 1. So I can write 9h square by a square plus k square whole square minus 81 by 4 k square by a square plus k square whole square is equal to 1. I can write like this. Okay, so or you can write 9h square minus 81 by 4 k square is equal to a square plus k square whole square, and therefore a square minus 9 by 4 k square is equal to, I divide by 81. Okay, so what I do, I divide this expression by 81, so I get a square by 9 minus k square by 4 is equal to a square plus k square whole square by 81. So this is the relation between HK, where HK is the midpoint of COC. Therefore, the locus of HK is x square by 9 minus y square by 4 is equal to x square. Replace h by x and k by y. So x square by 9 minus y square by 4 equal to x square plus y square by 9 whole square. So this is the desired equation of the COC. So you are asked to find the locus of midpoint, not COC. This is the desired equation of the locus of HK. Sorry, it is the locus of HK. So it is x square by 9 minus y square by 4 equal to x square plus y square by 9 whole square. So HK is the midpoint of COC, and from different points on hyperbola we could draw different pair of tangents on the circle, and we could get different COCs and midpoints of all such COCs, their locus of these midpoints, it will look like this, because it is nothing but the locus of Hk. So to analyze this problem, we use two techniques. One is writing the equation of COC as Tp equal to 0. Another way of writing the equation of COC is Dm equal to Sm, where S is the equation of the circle and T is the equation of the tangent to the circle, both at the point M, where as if assuming M is lying on the circle. So we use these two techniques, and from that we could derive the equation of locus of M or Hk as this. Okay, so this is a very useful technique for this problem. So we have solved this problem, and we have in background, as a background work, we discussed how the equation of COC can be written like Tp equal to 0 form and Tm equal to Sm form. And whatever analysis we have done, the same analysis is applicable for parabola, ellipse and hyperbola also. Instead of circle, had it been a parabola or ellipse or hyperbola, same type of treatment is applicable. You just work out in home what are the equations of COC for parabola, what is the equation of COC for ellipse, what is the equation of COC for hyperbola, both in this form and that form. Midpoint, if the midpoint is given, how the COC can be written, and if the external point P is given, how the COC can be written. For all the conic sections you can derive. If you find any difficulty, then please write to us. We will take another session to explain this thing for other type of conics. This problem appeared in one IIT exam, actually one year, and other type of conic section, many problems can appear, and if you understand this thing very clearly, then you can handle such problems easily. So I hope today's discussion was useful to you. You try to follow the steps, and if you have any difficulty, do not hesitate to write to us. We will take care of that. Thank you. Thank you for your patient listening. Thank you very much.